Okay, here is a study session video for our Chapter 6 Part 1 test. Going to be a little lengthy video, but it should help you for the test coming up. All right, so the first section for the study session here, we're going to talk about exponents, okay, simplifying, okay, using those properties of exponents. So first one, we got 2/3 squared times the quantity 6x y to the negative first to the third. Now, when we're doing this, there's so many different routes you can go about it, but it just is, you got to make sure you are following those properties of exponents. Okay, me personally, I like to take care of anything inside the parentheses first. So on the first one, we don't have to worry about anything there, but I could distribute that too. Okay, we got that quotient to a power, so I can take that power to both of the insides. Okay, so then times, and I can simplify what's inside there. Okay, 6x, and we got that negative exponent, so that y will go to the bottom. Okay, from there, simplifying each of those, 2 squared is 4, 3 squared is 9. Okay, now I got to cube everything inside of that next parentheses as well. So the next thing is saying 6 cubed, x cubed, y cubed. Okay, and then from there, I'm going to keep going. Okay, so multiplying again. So from there, we have 4/9, and simplifying that 6 cubed, we're going to get 216 x cubed y cubed. Okay, I'm going to move up here now. But then again, multiplying straight through, we're multiplying two fractions, so top times top, bottom times bottom. You're going to end up with 864 x cubed over 9y cubed. So then from there, I only have 1x, 1y. It's a matter of looking at that 864 over 9, and that would simplify to 96. So then we got 96x cubed over y cubed. Okay, if you got something like that, you will have your calculator, so don't worry about being able to simplify something like that on your own. Number 2 now, okay, I can go inside the parentheses there and simplify that. So I got x to the 4th, x to the negative 5th times x cubed. That's, again, we're adding our exponents. So we got negative 5 plus 3. We're going to end up squaring that eventually. So I have x to the 4th, x to the negative 2 squared. There I have a power to a power. So I'm going to multiply my exponents there. So I'm going to end up with negative 4. And again, we're multiplying again. So that's saying 4 plus negative 4, or x to the 0 power, which anything to the 0 power is 1. All right, on the next one. Okay, so I have the negative 63 over 18. I got x over x to the negative 2, y to the 9th over y cubed. Okay, so we got to simplify those. Negative 63 over 18. Okay, 9 goes into both of those. So divide top and bottom by 9. You're going to get 7 over 2, and we still got that negative. Okay, and then the next one, you got x over x to the negative 2. We can bring that negative 2 to the top to make it positive. So there would be 3 total x's in the top. So we'll have x cubed. And then 9 y's on the top, 3 y's on the bottom. So 3 of them will cancel out, leaving you with 6 y's on top. Okay, so if you want to break that down, you know, you end up with that negative 7/2. Okay, and then it'll be x to the 1 minus negative 2. So 1 plus 2, which is where we get that x cubed. And for the y's, 9 minus 3, which gets you that y to the 6th. Okay, that's using that quotient property. Top exponent minus the bottom exponent. Okay, so there is our answer for that one. All right, so for the next one, okay, again, when it's multiplying fractions, it's just top times top, bottom times bottom. So just think of this as one fraction. Okay, and I'm looking at 5 over 25. That's going to simplify to 1/5. Okay, so and then from there, I got x's. So I'm looking at my x's, squared, squared. So if we got x squared over x squared, those cancel each other out. Because if you think about it, so now we got 1. That's going to be 2 minus 2 because the top minus the bottom exponent. Okay, and then we got those y's on the bottom. Since they're multiplying now, negative 2 plus 1. So that will give me 1 over, and we got that 5 there still, sorry. Okay, negative 2 plus 1 will give me y to the negative first. we can't have that negative exponent, so we got to bring it to the top. Now the 5 is not with the y. The 5 has a positive exponent of 1, so that 5 will stay on bottom, so we got y over 5. All right, there is your properties of exponents. All right, so operations with polynomials now. Subtracting here, okay, we're looking for x cubes now. We have an x cubed, so there we're thinking 3x cubed minus x cubed, which will get me 2x cubed. And then the next one, you got x squared, and you don't have another one, so you don't have to worry about that. There we're going to get plus x squared. So then I'm going to look for my linear terms, the x's. I don't have anything there, so I'm not going to worry about my linear terms. And then finally, our constant terms. We got 1 minus 3, which will give us negative 2. So our answer is 2x cubed plus x squared minus 2. All right, on the next one, number 6, a little complicated one. Okay, we are multiplying. So when we multiply, we take the first term to both terms in the second binomial, second term to the other terms as well. So x squared y times xy cubed. Okay, x squared times x is going to give me 3x's, so x cubed. Y times y cubed will give me y to the 4th. Okay, so distributing it to that second term then, we got 3. X squared times x will give me 3x's, so x cubed. Y times y will give me y squared. Okay, so now distributing that negative 2x through. Negative 2, x times x squared. No, and then there's no other y, so just the y cubed. Okay, negative 2x times that 3xy now. That's going to give us minus 6. X times x squared, and then just y. So when we're looking to combine terms here, we're looking to see if there's an x cubed y to the 4th. There's no other ones. X cubed y squared, no other x cubed y squareds, no other x squared y cubes, and no other x squareds y. So there are no like terms here, so that is our answer. All right, number 7 here. This is where you have 2 routes you can go. Okay, you can just multiply it all out the long way, or you can use the Pascal's triangle using binomial expansion. Okay, I'll do it both ways here. So 2x minus 3, that's saying 2x minus 3 times 2x minus 3 times 2x minus 3 times 2x minus 3. Okay, so just concentrate on 2 of them. Okay, foiling those first 2, you're going to end up with 4x squared minus 6x plus 9. Now, those other 2 are exactly the same, so you'll end up with the same thing. And simplifying, adding like terms, we're going to get minus 12x plus 9. Okay, now we have to multiply again. Okay, this is why it's going to get a little more complicated, because it's very easy to mess up your terms here. 4x squared times 4x squared, that's going to give you 16x to the 4th. 4x squared times negative 12x minus 48x cubed. Then 4x squared times 9 plus 36x squared. Okay, so that's just me distributing the 4x squared through. Now distributing that negative 12x through. Negative 12x times 4x squared, you're going to get minus 48x cubed. Negative 12x times negative 12x, you're going to get 144x squared. And then finally, the negative 12x times 9, you're going to get negative 108x. Okay, so that's me distributing that negative 12x through. Now distributing the 9 through, you're going to get plus 36x squared. And then again, 9 times that 12, which we get 108x minus 108x. And then 9 times 9, you get that plus 81. From there, combining like terms, there's no other x to the 4th, so 16x to the 4th. Cube, and those are the only 2 cubes. So negative 48 minus 48, you're going to get negative 96x cubed. Okay, your square terms. So 36 plus 36, you're going to get 72 there, minus Oh, those are your only squared terms. So plus 72x squared. Then finally your x terms, minus 216x, plus that 81. Okay, so that's one way of doing it. Or you can use the binomial expansion. Again, you're going to need to be able to do Pascal's triangle if you know that. So 1, 1, 1, 1. Okay, and then going across, again, outside of the triangle will always be 1. And then to get that next term, you add the two numbers above. 1, 3, 3, 1, 1, 4, 6, 4, 1. And then each level is represented in an exponent. This is an exponent of 0. 1, 2, 3, 4, and it can go on forever. Okay. So if we're taking this to the fourth power, we want to use this level of Pascal's triangle. And if we do that, those are your coefficients. And again, you set up the two parentheses. So this will be me writing here for a little bit. And that's me just taking each of those coefficients from that level of Pascal's triangle. And then in the first parentheses, you're going to use the first term, so 2x. So 2x goes in the first parentheses for each term. And then for the second parentheses, you use the second term of the binomial, so negative 3. Okay, and then for the first parentheses, we started with the fourth, so 4, and then we go in descending order with the 2x. And then start with 0 on the second term, and then go in ascending order. Then it's a matter of simplifying from there. Okay, so we got 1 times 2x to the fourth. Okay, so that's 2 to the fourth, which is 16. So that's 6 times 16 x to the fourth. Anything to the 0 power is 1. Okay, so that's representing that first term there. So then for the second one, 4 times 2x cubed, which will be 8x cubed. And then times negative 3, because negative 3 to the first is negative 3. Okay, so then the next term, 6 times 2x squared. 2 squared is 4. X squared is x squared. Negative 3 squared is 9. Next term, 4 times 2x to the first, so just 2x. Negative 3 cubed, that will be negative 27. And finally, the last term, 1 times 2x to the 0, that's 1. Negative 3 to the fourth power is positive 81. So then from there, just multiplying it out, so 16x to the fourth. Okay, 4 times 8 times 3. Here you get 96, and you got a negative in there, so negative 96 x cubed. 6 times 4 times 9. You get 216, and it's positive, so positive 216 x squared. And then finally for that, the second to last term, 4 times 2 times negative 27, so negative 216. And you got x with that, and then 1 times 81, plus 81. Okay, either way you go, you should get the same answer. Okay, which my x squared terms, I forgot to add that 144. So there we should have got that 216 again. Okay, so if you won't have that long of one on the test, just remember that's going to be quicker if you know the process of doing it. Okay, you need to be able to come up with Pascal's triangle using those coefficients and then set up your parentheses and simplify each term. All right, so factor in the polynomial. Okay, here, no greatest common factor. So I'm looking for a special case, 2 terms, that's a good indicator of that. And I got x cubed, so this is a sum of cubes. What am I cubing to get x cubed? X. What am I cubing to get 64? That is 4. So then since it's a sum of cubes, we split it up into a binomial times a trinomial, x, 4. Then remember square, multiply, square. That gets you your terms in the trinomial. And then for your signs, SOAP, same sign, opposite sign, always positive. So that is factored form for x cubed plus 64. All right, for this one, it's not set up properly, so we got to take x to the fourth minus 6x squared minus 27. If it's set equal to something, that's when we're solving. Let's just worry about factoring here. So in this case, there is no GCF. Okay, so no, it is not a special case. So we're going to split it up into its two binomials. Okay, how are we going to multiply and get x to the fourth? You got x times x cubed, or you got x squared times x squared. Since we got x squareds here, it's going to be x squareds. Okay, our signs, we're going to have opposites. Okay, and then from there, how am I going to multiply and get 27? The one I'm seeing is 9 times 3. Combining those is going to get me to that 6. The 9 has to be negative, and the 3 has to be positive. Now remember, you can always check your answer. Negative 9x squared, 3x squared. Those two things should combine to get the middle term. All right, next one, 81x squared minus 9. We got a GCF in there, which is 9. Okay, so it would be 9x squared minus 1, taking out that 9. Then from there, I still have an x squared, so we need to factor that further if it's possible, and it is possible. It is a difference of squares. 1 squared is 1, 3x, that quantity squared is 9x squared, so 9 times 3x plus 1 and 3x minus 1. Okay, all right, there's factoring. So solving by factoring then, in this case we got 4 terms. Whenever we have 4 terms, we only have one method of factoring that, and that is factoring by grouping. Okay, group the first 2 terms. Oh, this needs to be plus 48. Group those first 2 terms, group the last 2 terms. We can factor out an x squared out of the first 2 terms, and we get 2x minus 3. And then in the next one, we can factor out a negative 16. Oh. That'll be 2x minus 3. Again, set it equal to 0 since we are solving. Now we have a common factors again, 2x minus 3, and then we're left with x squared minus 16 equals 0. In that next term now, or in this right here, that is another difference of squares, so we can factor that further into x plus 4, x minus 4. Okay, and then at that point, you set each factor equal to 0. Which ends up getting you x is equal to 3 halves when you solve those, x equals 4, and x equals negative 4. And again, we should have 3 answers due to it being a cubic function. All right, divide using long division now. Okay, so we set up our long division box. The first polynomial goes inside of the box. And x plus 9 will go on the outside. Then we're thinking x times what will give me x cubed. X squared does that. And then now multiplied times a binomial in front. X cubed plus 9x squared. And then at this step, remember we are subtracting. So what would probably help is put that into parentheses. X cubed minus x cubed is 0. 2x squared minus 9x squared, you're going to get minus 7x squared. Bringing down that next term. Now you're thinking x times what will give me negative 7x squared. That's going to be minus 7x. And then again, multiplying, so minus 7x squared. And then negative 7 times 9 is going to give you negative 54x. Sorry, no, what am I thinking? 63x. And then remember, we are subtracting, so those terms will cancel. Negative 57 minus negative 63. So really adding, we're going to get 6x. Bringing down that next term. X times what is going to give me 6x? That's going to be 6. 6x. When I multiply, 6 times 9 plus 54. Subtracting now. We get 4. Okay. X times anything won't get you just 4, so that is your remainder. And remember, when you write your remainder, it's positive, so plus 4 over the divisor, which is x plus 9. All right, divide using synthetic division now. Okay, so whenever you're dividing using synthetic division, remember you're going to take your divisor, which is x minus 1, set that equal to 0, which gives you 1. So that is the value that will go on the outside of the box. And then the coefficients from the dividend, or this polynomial here, goes inside the box. 1, 5, negative 1, negative 3, negative 1. Mama, bring down that first term, multiply, add, multiply, add, multiply, add, multiply, add. Now remember, going across then, here's your remainder, constant, linear term, quadratic term, and your cubic term. So our answer in this case will be x cubed plus 6x squared plus 5x plus 2 plus 1 over the divisor, which was x minus 1. All right, that was synthetic division. Now listing all possible rational zeros, remember p over q, with p being the factors of the constant, q being the factors of the leading coefficient. Okay, so my factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. Factors of 1 are just 1. Okay, for your factors now, remember, how can I multiply and get 24? 1 times 24 is 24. 2 times 12 is 24. 3 times 8 is 24. 4 times 6 is 24. So those are your factors of 24. Then from there, to list all the possible rational zeros, you're taking those combinations always again, and it's plus or minus. So 1 over 1 is 1, 2 over 1. Okay, so when we have just a one factor in the denominator, it's pretty easy. If we had a 2 in there, if that leading coefficient was 2, you'd have to go through and do the combinations with that 2. So 1/2, 2 over 2, 3 over 2, 4 over 2. And then don't rewrite possible solutions like 2 over 2. That would have been just 1. We already have that. Okay, but in this case, we did not have that. Remember, if you do get to that point, you need to take every single combination possible. All right, just give it a second here to get back up. Okay, so for the next part, solving. Okay, in this case, okay, there's 5 terms. Okay, we do not know how to factor that at all. So in these cases, remember, you're going to go to the calculator and you're going to find whatever zeros that you can. Okay, so in this case, we got y equals, and we're going to type that in, x to the 4th. Remember, you're going to use the caret top to get your exponent, plus x cubed. And always come down after you put your exponent, minus 2x squared, plus 4x, minus 24. Hit graph. Okay, if you don't get the negative 10 to 10, negative 10 to 10, make sure to hit zoom standard again. And on this one, it looks like it crosses through negative 3 and 2. So again, second trace. And we're going to look for a value here, negative 3. And it is a 0. Okay. And then let's check to make sure 2 was also, which it is. So we have 2 solutions that were given with the calculator. And let's go ahead and let's use that. And we're going to have 2 other solutions that we need to find. So we're going to use that synthetic division again to get to a lower degree polynomial. And this is just like we're dividing by x plus 3. And the other one's like we're dividing by x minus 2. Okay, so it does not matter which one you start with. Just make sure you don't repeat using them. And our coefficients for the actual polynomial, 1, 1, negative 2, 4, negative 24. All right, so and again, it's a 4th degree polynomial, so we should have 5 coefficients in there. Now, drop down the first coefficient, multiply, add, multiply, add, multiply, add, multiply, add. And again, if that is a 0, you should get 0 there. All right, from there, let's do another level of division. We use the 2, so we checked that that one was good, because anytime we find a 0 on a calculator, you need to prove them, remember. Okay, so let's prove that -3 is a 0. At 1, multiply, add, multiply, add, multiply, add. Okay, so that -3 was good. We need to find those other 2 zeros, and we're going to get that. Oh, constant, x squared. So now we got x squared plus 4 is equal to 0. Okay, we need to solve that. And by doing that, get x squared is equal to -4, square root both sides. Get x is equal to plus or minus, because we are in the process of solving. Square root of -4 is 2i. So we got positive 2i and negative 2i for those other answers. Okay, next one. 81x to the 4th equals 16. Now in this one, okay, we got to get it set equal to 0. So 81x to the 4th minus 16 equals 0. Okay, then from there, we can try and factor. I noticed that this is a difference of squares. Okay, 9x squared, 4. So 9x squared plus 4. 9x squared minus 4 is equal to 0. Okay, you could set each of those equal to 0 and solve from there. Let's go ahead and let's do that. Okay, so 9x squared equals -4. Divide by 9. And you get x squared is equal to -4/9 square root. You get x is equal to plus or minus. Square root of 4 is 2. Square root of 9 is 3. And I took the square root of a negative also, so I. Okay, on the next one, 9x squared minus 4 equals 0. 9x squared is equal to 4 then. So x squared is equal to 4/9. Square rooting both sides. You're going to get x is equal to plus or minus 2/3. Square root of 4 is 2. Square root of 9 is 3. So there are my 4 solutions for that answer. Now you could have factored that further. It's going to get you to the same exact answer. All right, for the next one, okay, try, again, always try to factor. So we're going to set this equal to 0. Okay, and we're looking for that greatest common factor. In this case is x. That'll leave me with x squared minus 5x minus 14 equals 0. Factoring further then, we don't have a special case. We already took the greatest common factor out. X times x. Signs have to be opposite. 7 times 2 is 14. They can combine to get -5. I need more negatives, so 7 there, 2 there. Setting each of those factors equal to 0 now. X equals 0. You don't even have any solving left to do there. X plus 2 equals 0. X minus 7 equals 0. So x equals -2. X is equal to 7. So there are our 3 solutions for that polynomial. All right, so use synthetic substitution to evaluate the polynomial function for the given value. In this case, remember, synthetic substitution, we're basically just evaluating. We're plugging that in using this specific method. Okay, 3 goes on the outside. Your coefficients now again, x to the 4th, x cubed, x squared term, it's missing, so we got to represent that though still with 0, 1, and -5. And then we bring down that leading coefficient, multiply, add, multiply, add, multiply, add, multiply, and add. Okay, so f of 3 is equal to that -56. All right, so remember, know the difference between synthetic substitution and synthetic division. All right, describing end behavior now. Remember, as you're doing this, it's always as x approaches infinity, what is the function doing? And as x approaches negative infinity, what is the function doing as well? Now in this case, we got a cubic function, so that's odd. So end behavior is going in opposite directions, and we have a negative leading coefficient. So just think about it like negative slope. That's not what the graph will look like, but that's what the end behavior will look like. So as x approaches infinity, again, as we go right, the graph is going down, so it's approaching negative infinity. And as we go left, as we approach negative infinity, it's going up, so it's approaching positive infinity. That is our end behavior. All right, so here we got x to the fourth, so an even degree. So the end behavior is going to go in the same direction. Positive leading coefficient, so we're going up. So as x approaches infinity, f of x is also approaching infinity. As x approaches negative infinity, f of x is also approaching positive infinity. All right, that is end behavior. Now, write a polynomial function, f, such that as x approaches infinity. So when I do these, I like to draw out what's the end behavior doing. As x approaches infinity, f of x is approaching negative infinity. So as we go right, we're going down. As x approaches negative infinity, f of x is approaching negative infinity. So it's going down again. So we have end behavior that's going in the same direction, which tells it has to be an even degree. So when I write this function, f of x, x to some even degree, 2, 4, 6, 8, any of those. And since it's going down, we need to have a leading coefficient of a negative value. All right, graphing now. So when we're doing this now, make sure you have the correct end behavior, and I need to see this table of values. Okay, the x values that we're looking for to evaluate, -2, -1, 0, 1, and 2. Okay, so again, synthetic substitution for you guys is probably what's going to be best. So let's go ahead, let's do a couple like that. So let's evaluate -2. Now we got x cubed, so 1, no x squared, so 0, -4, 1. Bring that leading coefficient down is 1. Multiply, add, multiply, add, multiply, add. So when x is -2, f of x is 1. Now, I highly recommend you guys do that all the way through. For the rest of these, it's going to be 4, 1, -2, 1. Okay? But to get those, use your synthetic substitution. Now, from there, now we have points. -2, 1, -1, 4, 0, 1, 1, -2, and then 2, 1. Plot those points, -2, 1, -1, 4, 0, 1, 1, -2, 2, 1. And now, we have an odd degree function, so we should be going in opposite directions, and it's a positive leading coefficient. Therefore, it should look like a positive slope, so I should end down here and end up here. So let's make sure we do that. So when we're doing this, I always work from left to right, so I'm going to have to go through those points, and again, flow through the points. Do not play connect the dots. All right, and then also this is a cubic function, so the maximum number of turning points that we should have is 2. It's always 1 less than the degree. Okay, and I got 1, 2 turning points, so we're good there. And so remember, when I grade these, I'm going to look at the end behavior, I'm going to look at your table, and that how the graph actually looks. Okay, looking at the turning points, making sure that it flows through your points and not just playing connect the dots. Okay, decide whether the function is a polynomial. If it is a polynomial, answer the following question. If not, do not fill in the blanks. Okay, so when we're trying to determine if something is a polynomial, again, we need to have whole number exponents. Okay, so 4, 2, x. X is not a whole number, so in that case, this is not a polynomial. Okay, that's the first part. Okay, it was not a whole number, so we don't even need to worry about that one. On this next one, okay, we got 2, 1, 7, and a constant. It's like we have an exponent of 0, so we're good there. And then we got to look at the coefficients. We have to have real coefficients. In this case, we got -1, -4, 8, and 1. Those are all real numbers. Okay, if it is an imaginary, you're going to see some type of I or like a square root of a negative value. That's a case where we have an imaginary coefficient. So we are good here. We are a polynomial. In standard form again, remember, the largest exponent will come first. Okay, so that 8x squared, 8x to the 7th. And then x squared, so minus x squared, minus 4x plus 1. When you're in standard form, look at your coefficients going descending order. Okay, now once we're in standard form, degree and all this other stuff is pretty easy. Degree, we look at the first term, degree 7. Okay, if we classify by degree 7, we just say degree 7. Remember, degree of 0, that's constant. Degree 1, linear. Degree 2, quadratic. Degree 3, cubic. Degree 4 is quartic. After that, we're just going to say degree 5, 6, 7, whatever the actual degree is. Classify by number of terms. 1, 2, 3, 4 terms. Okay, so remember monomial, binomial, trinomial. Okay, and then once we get to 4, we're just going to say polynomial. Poly meaning many. Okay, and then finally the leading coefficient is just going to be that first coefficient you see in standard form, which is 8 in this case. All right, so I know that was pretty lengthy, but I believe it will help you greatly for the test. If you have questions on it, let me know. Otherwise, have a good day.